Hello, and thanks for joining us for our webinar today on data security challenges and benefits for organizations that are adopting open source software. First, to go over some logistics, we're going to be handling any questions during the webinar through the Zoom webinar question interface. And you should be able to type out any questions, and we'll either try to answer them in the course of the webinar or we'll answer them at the end during a Q&A session. You should be able to see the button for asking any questions at the bottom of the Zoom webinar application. Also, this webinar will be recorded and will be available online as soon as we have finished processing the recording. So everyone who registered or attended this webinar will receive a notification at that time with a link to the recording of the webinar. And you can use that to view it yourself or to share it with anyone that you think would find it useful. So with that, to go over the agenda today, I'll be starting and introducing myself as well as Shruti Kulkarni, who is joining me today as expert on open source software. I'll hand it over to Shruti, and then she will go over some of the benefits of open source software and as well as some of the security challenges in organizations implementing open source software. Um, there's then she'll go over like how to address some of the challenges associated with open source software, and then she'll hand it back to me, and I will go through, I'll give you a little bit of background on NextLabs, as well as how we can specifically help with some of those security challenges associated with open source software. Finally, at the end, we'll open it up for some Q&A. Again, you can type out your questions anytime during the webinar, and we will answer them either during the webinar or at the end. So that, I'd like to introduce myself. My name is Tony Burning. I'm a senior product manager here at NextLabs with a background in enterprise security. And I am very pleased to welcome to the webinar today, Shruti Kulkarni, who has also contributed and worked with us as a security expert in the past in our expert security series. I'm sorry, our expert Q&A series, which you can view online on the NextLabs website and YouTube channel. Shruti, I'll hand it over to you now to continue to introduce yourself, and then you can take it away with content.
Thank you, Tony,
Mhm.
for the introduction. So I'm Shruti Kulkarni. I'm a cybersecurity architect. I work for 6.6, which is now a part of Accenture. In my role as a cybersecurity architect, I do threat modeling. I analyze solutions for security requirements. I help the development team, operations team implement security controls in their respective areas. And in the past, I worked as an information security manager and as a security analyst. So that's about me, Tony. So I want to, because the topic of today's webinar is open source software, I want to start off by giving a little bit of an introduction about software. I'm sure many of you, I mean, most of you know what software is, but I want to give a different perspective to it. So, we have applications and software everywhere. So here, for the purpose of this webinar, I'm using both software and applications in an interchangeable way. So don't worry about it if I use software at some time and application at some time. Typically, the world is made up of applications and software. There are various types. For example, we have operating systems, we have web servers, application servers, database servers, you have firmware for firewalls, firmware for IoT, browsers, you name it, there is an application for it. So the world runs on applications, except of course when it is bare metal servers, which we are not considering over here. But nonetheless, these are all applications and or software. Now, to build an application, there is very little that goes by in terms of requirements. For example, all that we need to build a software is some source code and developers. So you don't even sometimes need an IDE to develop your applications. You can write your source code on a notepad and save it with the extension like .java or .c, and then you can use a compiler and compile it into software. So by way of building a software, it takes very little. And if we were to categorize these into categories, you typically have something called a proprietary software and an open source software. So proprietary software is something where the source code is not known. Open source is something where the open source code is known. So there's also another category of shareware, but we are not going to get into that because that's not really a very widespread type of application, so to speak. Now, let's see. So I did mention that the world runs on software, which is true. And then as you can see, I've listed down the types of applications on the left-hand side, and you see that there is a proprietary software and an open source software for each of those categories. Like for example, if you're looking at operating systems, you can see that we have open source operating systems in terms of GNU, Linux, or Ubuntu, and then you have a corresponding proprietary software like Windows and Macintosh. Then you've got web servers. The open source are Apache HTTP server, Apache Tomcat, Nginx. The proprietary version of it is IIS. So all I wanted to illustrate on this slide is that we have both, for each application, we have both open source software and proprietary. It's just to give you a flavor of how popular open source softwares are. So why should you attend this webinar? Now, open source software, or OSS, as it's properly known, is a part of applications. We just saw that for every proprietary software, there is an equivalent open source software. As security professionals, we are often called upon to advise or, help consult on the use of open source software. As security consultants, we need to give our advice whether a particular open source software or a software is suitable and is aligned to the security policies that the organization adopts. And sometimes concerns are raised about security of open source software. There is always, there can be thought processes around lack of security being a factor of consideration for open source software. So whilst, there are concerns or lack of concerns have their own perspectives, I think open source software is here to stay. I don't think open source software is anytime going to go away and anytime soon. So that's why if it is there around and if there are, really good applications written in open source software, I think it's time that we talk about OSS and how it can be used securely. I think it's also time to talk about the various aspects of security of open source software and how we can make open source software work for us. As much as we use the software, it should work for us as well. So that's what we're going to talk about in this webinar. What is not in the scope of webinar is we're not going to talk about development and deployment of open source software. Neither are we going to talk about the contribution to open source software. Though we will touch upon the contribution a little later in the webinar. A little bit about the history of open source software. It's been around for quite some time, since, early 90s, when Richard Stallman talked about launching a new project. Then there was the free software movement, which meant that, people shouldn't be paying for software, and then there should be freedom to exchange software and modifications. Now, in 1998, Netscape did announce the source code, open source code release. So this is all taken from Wikipedia. This is not what I am saying. It's just available on public network. Now, so why do we need to use open source software? What is it that differentiates open source software from proprietary software? It actually opens up possibilities. You can just start an open source software on your own. You don't need any permission for that. You can go to GitHub or GitLab or any such, code repositories and start your own project if you have a good idea for it. And if you're using open source software and you want to improve the code, you can do that. There's nothing stopping you from doing that. You can extend the code or features of open source software that is already available. So in doing so, it provides you learning opportunities. Like, you can really think about various cool features that you can include in the open source software, and you can look at writing the code better. And in that whole process, it actually fosters creativity. You can be as creative as you like. Um, and also, when we actually use open source software, it lowers the total cost of ownership. We'll touch upon the total cost of ownership later on in terms of licensing and how it helps. But I just want to bring that angle over here that it does help in lowering TCO. There are a lot of solutions that run on open source software, like Tomcat or Nginx, or using LibreOffice, which is open source equivalent of Microsoft Office. And then it widens the test participation. So you can always invite developers or testers to test your code. And more the people use your open source software, the test bed widens, so to speak. Then also you have opportunities for contributions in terms of testing, reporting findings, fixing findings. It's just that you're not restricted by any organization, because you can invite and you can participate yourself in terms of testing and reporting findings. Then it's of course a platform for showcase of talents, and it's innovation through collaboration. So it provides space for leadership. So, OWASP is kind of a leader in open source software. There are a lot of tools that are open source, and then people contribute, and it does. There are lots of flagship projects in OWASP. That's just an example I'm saying, and that's not the OWASP is not the only open source software organization. I'm just saying that it provides space for leadership, and of course there are definite benefits which I have not listed down over here. So, when we have opportunities and we have benefits of using open source software, there are also some myths surrounding open source software. The key one is, I can modify the code of any open source software and the modifications get added to the deployment packages. Well, no, not really. So if I go ahead and then download the source code of, say, Notepad++, and I modify it, it doesn't get distributed everywhere. It has to get into the main repository. And for that, you need to get invited to contribute. We'll touch upon that later on in the webinar. I just wanted to bring out that point that, this is just a myth surrounding open source software. There's another one which says, I don't know who the creator of the software is, neither do I care. No, you need to care about it, because there are licensing implications of using open source software. So there's another one of that, if a piece of code doesn't have an owner, it is open source. No, somebody has written the code, somebody owns it. It's just that we don't know who the owner is, so it just automatically doesn't become open source. And then if code is made available in public forums, it's open source and can be used without crediting the creator. No, every open source software has a creator, so you need to credit the creator of that source code. So these are some of the myths. We'll talk about them. And of course, the biggest one is open source software is free. Well, in a way, yes, but there are licensing implications, which we'll touch upon later on. So open source software doesn't mean it's free. So when we are talking about open source software, we'll talk about these considerations. What about the vulnerabilities in open source software? What about the supply chain risk? What if there are lack of updates to the software that I am currently using? What are the dependencies of that? How does copying source code off public domain impact me? And what about the secrets left embedded in the code, and then the licensing bit of it? So we're going to talk about all these points. So let's touch upon the vulnerability side of open source software. So like any other software, open source software may have vulnerabilities, may be outdated, may be out of support, and lack patches. Sorry, I just had a sip of my tea. So, open source software are not free of vulnerabilities. That's what I want to say. And then there is the supply chain risks. So the point is, open source software is included in commercial packages. For example, if there is a software as a service that is running, They can include Tomcat or Apache web servers. There's nothing stopping them from doing that. They can use, any open source databases like MySQL. It's quite possible. And another key thing is open source software gets included in other open source packages. Like, for example, there are a lot of, machine learning models that are written in Python, and then Python itself is built using C programming languages. If you see where I'm coming from, there is a supply chain involved right from the creation of one, a chain of software, which could also be included in open source software. So what this means is that attackers can scan a particular application to discover vulnerabilities within open source software, like Log4j. That was investigated. Then there was the Bash vulnerability that was discovered. So there was also a point about a malicious package or an open source software making its way to a known repository. For example, if you are pulling off your open source packages from a well-known repository, because of typo squatting or some kind of a lack of testing, or malicious packages may make their way through to the repository. So the problem is when there is a lack of governance gates, attackers may inject malicious backdoors, malicious code. That's also a possibility, and that can lead to supply chain risks. And using default settings in open source software could also lead to increase in risks of an exploit. So like any other software, open source software also can have zero-day vulnerabilities. Now, just because, we talked about these vulnerabilities and supply chain risks, and we also know that the source code of open source software is open, so people can scan or review the code and know the vulnerabilities. But once open source code is reviewed and viewed, can it be modified by anybody and everybody? Well, technically, yes. So open source software is based on licensing, and some licensing require that source code be made available when the licensed material is distributed. Some do not. So contributions to open source software is by grant of access to source code. So whilst everybody can download the code and view it and review it, not everybody can contribute to the main branch of the repository. So that's why not everybody can make changes to the source code of open source software and distribute it to end users. All I'm trying to say is that if you're using Ubuntu, and if I have made changes to Ubuntu, it doesn't mean that you get those changes. No, I should have been involved in managing and in merging my code into the main repository before you get it. Then there is also the fact that because anybody can download the source code, vulnerabilities can be discovered. It's just that it gives an attack path to attacker to exploit the vulnerability, but that doesn't mean that every instance or every installation of the open source software can get exploited. It's just that the probability of exploit is higher depending on what sort of controls are put in place. So if you're probably using the open source software in a very internal part of your organization, which is not really exposed to the external world, then the probability of the exploit is definitely lower. But if you're putting it out on the public facing applications, or it can be discovered from a scan, then yes, the probability of the exploit is higher. And then, like any other software, open source software has vulnerabilities, which I touched upon earlier. And then it may lack updates because the creator or the contributors may cease development. So yes, lack of updates is a consideration when you're trying to use open source software. And the key one is licensing. So what does licensing mean actually? What licensing actually, I will see the examples of licensing later on in the webinar, but what it really means is that it gives you permissions and constraints as to how access to the software can be obtained, how to include software in your offerings. And then can you share the source code with others if you modify it? Or do you have to pay the creator if you modify the software and sell? Or even including the software in your solution, and if you use it for commercial purposes, do you have to share pay a price for that with the creator of the software? So all these are actually included in your licensing part. Um, so that's what actually means when you talk about licensing. So when we talk about licensing, licensing is not equal to pricing because there are other aspects. The creator may not expect a price if you include open source software in your solution, but they want credit for it. So you may want to, disclose that on your website or something where you are actually repackaging the open source software and then presenting it to your customers. So it doesn't always equate pricing. Also, at the same time, open source doesn't always mean it is free. So there may be financial and commercial implications for open source software, using open source software. So what licensing and ownership means is that it provides permissions for certain actors, for certain actions, and constraints while carrying out the actions. So permissions for certain actions is ownership, and then what the corresponding constraint is whether it's a copyright, and then licensing, whether it's copyleft. So there are permissions and constraints. Let's see what it means like in real life. So this is the new general public license. So as you can see, new has permissions for anybody who is using new. They have permissions to commercially use it. They can distribute it, modify it, patent use, or private use. But the constraints are that they disclose the source, they put the license and the copyright notice when they use it, and then the network use is distribution. So it has to be under the same license. You cannot change the state. So that's what I mean by constraints. And then there are, of course, the limitations because it's a part of the licensing package where it talks about liability and warranty. And on the right-hand side, you see some examples like, your Apache 2.0 license type is used by O. Actually, it's no longer O for Zap, it's just Zap now. And then Apache license V2 is used by OpenSSL. SSPL and Apache license 2 is used by Elastic. So there is a license type and there are examples of it. You can have actually attributed the source over here. It's called chooselicense.com. You can go and have a look at it. It's a very interesting website to go through. Now, we talked about this. To make a software, all you need is some source code and developers. Now, your software, open source software, actually can be in various formats. Like, you can have source code like GNU. There can be open source packages like NPM. Then there are precompiled code like NuGets. Then there's APIs and applications. But ultimately, they all whittle down to two categories: whether the creator of that open source software is distributing binaries or precompiled code, or they are making the source code open and requesting for contributions. Eventually, that's what it whittles down to. So as a part of source code, binaries, and precompiled code, for binaries or precompiled code, there usually exists a development team, either with one developer or several developers. What the creators of the open source software, binaries or precompiled code do is that they manage a staging area, like feeds or a downloads page, and then put their binaries in the staging area for the consumers to download and use them. So the examples of this are NPM packages or NuGets. The other one is source code. So when the source code is shared with everybody, not, as I explained earlier, not anybody and everybody can go and make changes to the source code. There is a collaboration. So for the code repository, usually the creators of the software that for which the source code has been made open, they invite the developers in and then grant access to the developers' requests. And only then developers can go and make change to the source code. Otherwise, they cannot. Binaries, you have to be a part of the development team to make changes to the source code. So you see, there's a difference actually. So development binaries are more kind of closed because of the presence of a development team. With source code, it's more open, but then nonetheless, you still need to get invited, and then you need to get access to make changes to the source code. So here are some examples. Some developers are employed, like for example, Elastic, then OpenSSL has contributors, Zap has volunteers, and consumers, actually open source, so consumers actually consume this open source code. So these are some of the examples. So we have talked about what it means to open source to create a software. That is, we need some code, we need some developers, and how do we actually, what it means to distribute or open source software. We know we have to attach a license to it. We have talked about the considerations, the vulnerabilities, and then the updates and the supply chain risk, and how do we actually attach licensing to make sure that not anybody and everybody can contribute to your source code, and how to invite developers into certain projects, and how to be a part of a development team to create certain open source binaries and packages. Now, we need to ensure the security of it as well. So if you remember earlier in the under considerations, we talked about how to use secure configurations or how to use security features for open source software. Now, these are some of it. So because supply chain risk is quite real for open source software, when binaries and precompiled codes or packages are used, it's always recommended that you use signed binaries or packages. You reference one private feed and do not spread it out, and use controlled scopes and log files to make sure that malicious packages or typo squatting does not take place, and you use a genuine package or a precompiled code. And there is also the part of testing. So if it is within the budget of your organization, use a SCA tool to scan for vulnerabilities of the binaries and precompiled code that you have used. Now, the second consideration is vulnerabilities. So to address that, for the binaries and precompiled code, where possible, use version pinning. So, again, to avoid any kind of a poisonous or a malicious code entering into your code, into your package. And where possible, use integrity verification. So actually, when you're downloading the package, you want to make sure that whatever you selected has been downloaded. So you can compare the hash of the binary or the precompiled code and make sure that it is the right one that you have downloaded. That's another way to do it. So when you have, during your security testing phase within your organization, you can also check for vulnerabilities in, vulnerability disclosure databases like CVE database or vulnerability DB for the binaries and the precompiled code that you've selected for yourself. Also, when you have included them in your application, you may also want to do some dynamic application analysis or pen testing, just to make sure that the binary or the precompiled code doesn't manifest any vulnerabilities when the application is running. To address lack of updates, you can monitor for deprecated packages. So if anything is not supported for a long time, and that the code may or may not be secure, sorry, the binary may or may not be secure, just don't use deprecated packages. And then you can also check for dependencies using dependency graphs, and you can log files. And then the last one is when you're copying source code off public domain, if you're thinking about it, don't think about it, don't do it, because you don't know what you violate. And then when actually someone looks at your code, or if you open source it, it may get discovered and it may not be nice for you. So we talked about the binaries, precompiled code, and packages. Now, the next one is when you are thinking of using source code. That's open source software source code. You can do that, right? You can download the source code from GitHub, and then you can use it as a part of your application. So again, to ensure that supply chain risks do not materialize, you may want to check for dependency graph. This is for GitHub. I'm sure GitLab has an equivalent of it. I haven't included it over here. So check for dependency graph. Also check for dependabot alerts, because when you include open source software, and as I explained earlier in the webinar, the other open source software can also be included in the one that you have selected. So to ensure that just because your open source software or the one that you have chosen to include in your application does not have vulnerabilities, it doesn't mean that the supply chain, the whole chain of open source software that is built upon, doesn't have vulnerabilities. So Dependabot gives you that kind of an alert. Then, when you're committing and tag, use commit and then tag signatures so that you can avoid that kind of supply chain risk materialization. Again, of course, when you're testing, make sure that if your company, if you have budget for it, try and use an SCA tool, that is software composition analysis tool, to scan for vulnerabilities. And then if your source code that you're downloading and using in your application, open source software, is small, then definitely you can review it, personally. But what if the source code is huge? It runs into hundreds and thousands of lines of code. You definitely can't sit and then review it manually. So you can actually address the vulnerabilities in the source code of the open source software that you've chosen to use by using, CodeQL in GitHub. I'm hoping they still provide for CodeQL. I haven't checked for it today, but that that's available. Sort of, it's available. Then you can also, check for vulnerabilities using static code analysis tools. And you can always, run dynamic application analysis and do pen testing. And again, for lack of updates, monitor for deprecated dependencies. And also, if if the source code for an open source software is not supported for a long time, and if the lines of code run into hundreds and thousands of lines of code, then I would recommend that don't use it. Find an equivalent for it. There are plenty of open source software equivalents for but whatever you're trying to use. If not, write it yourself. But I would recommend don't use deprecated dependencies, sorry. And then you can always use static code analysis to check for any kind of vulnerabilities in your code. So again, for dependencies in GitHub, you can check for dependency graph. And if and always, it's always good to check for any embedded secrets in your code, whether it is your own code or open source software source code. Please scan for secrets, because if you have embedded secrets, it can leave a door open, and it is actually a backdoor in your software. Again, if you're copying source code of public domain, don't do it, please. So what does it mean then? If you take a step back, using open source software is not bad in itself, because there are various mechanisms to check for the security and check for dependencies, embedded secrets, etc., etc. But that still doesn't replace your SSDLC processes. So from a security perspective, it's always good to have SAST, DAST, pen test, vulnerability scans, vulnerability disclosure program, to ensure that whatever open source software you're using is secure. So in the grand scheme of things, whether you're using proprietary software or open source software, it doesn't, we can't get away with from policies, processes, procedures, standards, and guidelines. It's always good to underpin all your usages of your open source software or proprietary software with a policy for secure development lifecycle, You should always use processes for security requirements, threat modeling, code review, testing, triaging of results, acceptance criteria, and vulnerability scanning. You should always have procedures for usage of tools and then standards for secure coding. And also, how exactly do you use open source software, and how exactly what sort of licensing you want to use. They all become a part of your, policies, processes, procedures, standards, and it's always good to flow all of them under secure SDLC. So that also including guidance for validation and verification of security in products and security of products. So don't do away with SSDLC. Um, there is nothing wrong in using open source software. I'm a big fan of open source software. As I said, there are lots of reasons why you want to use open source software, but use it in a secure manner. So you don't have to worry about the security of open source software. In summary, open source software gives you a lot of freedom and expression of creativity. But the security of open source software is as much a consumer's responsibility as a supplier's responsibility. So follow the security principles that your organization may have. If not, we have listed down some security controls for binaries and for source code. So use them, try and see what fits into your organization's appetite. Use open source software in an informed and a secure way. That's all I have. And may I hand the screen back to you, Tony? I'll stop
Absolutely.
sharing my screen.
So, thank you, Shruti. Now, I want to spend just a little bit of time specifically tying in what NextLabs does and how that ties into some of the concepts and challenges that Shruti was mentioning when it comes to the security aspects of open source software. So, just a little bit of background on NextLabs. So, we are a leading provider of zero trust access management and data protection software, and we have many customers within the Fortune 100, as well as many different government organizations and other large organizations that have very complex environments, including in most of these. If I would just say, yeah, leave it at most. In most of these organizations, whether they're again government or just large multinational organizations, they have adopted some elements of open source software into their environment for a lot of the positive reasons that Shruti mentioned. Um, However, what that means is that they have hybrid environments a lot of times where it's like partially open source, partially a proprietary software, and they use us to handle their security needs for these complicated environments. We have a number of also strategic partners that we work with, worldwide go-to-market and partners, including Microsoft, SAP, Siemens, IBM, Accenture, Deloitte, Infosys. A lot of them have developed open source software and that approach to varying degrees. Um, we've also been endorsed by the National Institute of Standards and Technology, as NIST, as part of their National Cybersecurity Excellence Partnership Program. We have a number of different technology patents and with many still pending. So um, our main products, our product suite, the four elements in our product suite, Cloud AZ is our unified zero trust policy platform. That's really the backing of everything that we do and helps us enforce data security policies across organizations. And then we have three different enforcer line of products: application enforcers that provide externalized authorization management and enforce data access policies within the application layer. A data access enforcer, or DAE, which enforces policies in the data access layer. And then Sky DRM is our digital rights management product, which enforces policies on files and unstructured data. So again, and those work across organizations to protect data throughout the data life cycle. The the main problems that we solve is really helping organizations balance the need to share with the need to protect. I'm not going to spend too much time on this because I think it's pretty straightforward. But more and more, there's a need to share information to work with partners and within organizations. However, a lot of that data still needs to be protected, and so where we come in is we are able to provide a solution that allows our customers to protect that data wherever it is throughout its life cycle without slowing down the need to share and the need to collaborate. The way that we do that is by providing that centralized policy management and then enforcing that within different applications. Again, whether they are open source or proprietary applications or within content management systems or protecting unstructured data as well. So we really do wholeheartedly uh, not just buy into or support, but like have been one of the contributors to the ideas of zero trust has been promoted by NIST. So we've been a very early contributor, collaborator with NIST, and in these very complex environments, we actually believe that it is more important to adopt the principles of zero trust. So every time something protected data is being accessed, that's you need to validate the authority or the rights of the user, the device, or the entity that's accessing that data at that time. You don't assume that because they've gotten access to a secure network that they should have access to everything. And this is very true when you have many different types of systems like hybrid environments, such that include both open source as well as proprietary software that all may have different security libraries or underpinnings. We believe that it's very important to have a data-centric approach and enforce the access to that protected data on a very granular level every time that data is accessed. So these principles are integrated throughout our suite of products. As I mentioned before, Cloud AZ is the unified policy management platform where you can define policies to be implemented throughout your organization. And then those policies, you can either have Cloud AZ and work with it directly through the APIs and the SDKs, um, or we have the products that enforce those policies at the different um, at points of access. So SkyDRM protecting the files, persistent protection that stays with those files even as they're shared outside of the organization, or application enforcers that enforce access to that secure data within applications, and then finally DAE or data access enforcer, which enforces um, data security policies when data is accessed at the data access layer, so in between the application and the database. I mentioned we have a number of different patents that, especially in the areas of zero trust architecture, data-centric enforcement, and dynamic authorization. We've been working in this field for quite a while and have a deep amount of technical expertise in these areas. So I will jump through here just for the in the interest of time. But I really wanted to emphasize this approach, which we think is very applicable to again to hybrid environments and organizations that have adopted a philosophy of using open source software for their critical applications. Our approach is that first of all, knowing your identity, knowing which systems it's stored on, knowing what type of data you have, and the types of individuals that you have accessing that. Um, so that you can identify which data needs to be protected and who is able to access it. So this could be whether data is classified, where it's stored, and then from the identity perspective, where you have individuals accessing it from, and like what sorts of clearances they have, and if there's any regulations that apply to access from different areas. Protecting data at the source, so that's where it's created within the applications. Um, And that's where our application enforcers come in, protecting data in transit and at rest. So at rest, if it's being stored within databases, that's where our data access enforcer product comes into play. And then in transit, when it's being shared using SkyDRM, so our digital rights management product that allows you to attach protection to a file, and it is protected when it's being shared within an organization or in other organizations. Our fourth item is protecting data in use. So that means that when it's being used within applications, and then finally, automation and orchestration is a key part of our approach. So um, with our approach, and I'll get into this in the next slide, you can automate the process of defining policies and applying those policies, enforcing those policies. So you take away a lot of both the manual effort and time needed to define and enforce data access policies, as well as you reduce the risk of any sort of human error or gaps in those policies when you automate it and uh, automate the application and the orchestration of the policies. And then the final element is visibility and analytics, which means that um, because we have a centralized, unified policy platform, we also have centralized like activity logging that shows you where your critical data is being accessed across the organization, who's accessing it, when they're accessing it, so that that data can be used to identify if there are any potentially suspicious activities, even if someone is probing in different areas for potential vulnerabilities. So a little bit of an example of what an attribute-driven policy is. I haven't um, uh, gone too much into this, but like all of our policies are attribute-based access control policies or ABAC policies. That means that they are written in terms of specific attributes of the subject, so the individual or the device or the entity that is requesting access. Attributes of them, like what's an individual's title may be, what sort of clearance they have, where they're accessing it from, what office they are. A what office they are assigned to and should be accessing it from. The environmental attributes. So when the request is being when the request is being is originating, where it's coming from, what networks it on, what device, what IP address, the environment or the context in which the access request is originating, and then also resource attributes. So what is being the attributes of the data that's being accessed. So is it classified? Is it restricted? Is it covered by any regulations? So all of those combined then can be incorporated into a policy to allow you to define a very small number of policies that cover a wide range of different data security situations. Specifically, as it applies to open source software, one of an example of of how you could use this is as Shruti mentioned, you need to be checking the versions of any packages that you're using and making sure that nothing that you're using has been deprecated. So you could write a policy to say that if this data is being used or being accessed by this application, this open source application, only allow that access if the version of the software has not been deprecated, or if it is the most recent version available through a public archive or public repository. So you can build that in. You can make those checks automatic. So and then our software will allow you to uh, check those attributes and the values of those attributes to evaluate the policy at the time of the data access request, so that you can ensure that you're always making that the decision is always being made with the current values of the attributes. So, so that's a brief overview of NextLabs and how it relates to the topic of open source software security. Say now we will open it up for any questions that you may have. I will just to reiterate, uh, this webinar will be recorded, and we will post the recording and email everyone who registered after the recording has been posted. And please do share it with anyone that you think would find it interesting. One question that I have to start us off is for for organizations that are using a product like NextLabs with open source software, and building an integration using the NextLabs APIs and SDKs, are there any licensing concerns um, with the licenses associated to open source software? I'll take a stab at this, and then I'll turn it over to the expert, to Shruti, to confirm that I'm answering correctly. But I believe that you should be able to modify any open source software to then build in those integrations, as long as you're not then repackaging that software and reselling it. There shouldn't be any copyright concerns. But I'll hand it over to Shruti to speak a little bit more authoritatively on this topic.
Um, Thank you, Johnny. So, in open source software, which has a license that allows you to repackage and sell it again, you can do that. But if your license has a constraint on whether you can include your modifications in the software or not, that's a different question altogether. But yeah, essentially, I agree with you, Tony, how you mentioned it. But I would keep a little closer eye on licensing and the constraints that it offers.
So a little bit of it depends. It depends on the specific
Yes,
license that it's governed by, uh,
yes.
and whether. Okay, great, thanks. Shruti, are there any other topics that either uh, my portion of the webinar raised for you, or that you wanted to tie in as a closing thoughts? I don't see any other open questions right now, but we definitely have some time to cover any additional information that you wanted to include as a
Um,
closing thoughts.
Sure. Actually, I just want to give a little bit of a spin on how zero trust applies to open source software.
Mhm.
Is especially because open source software has implications around supply chain risk materialization, ensuring that when the open source software is being built, applying zero trust policies to that really helps a lot. Because basically all zero trust is telling is that you avoid implicit trust. So make sure that whoever is accessing your code or making changes to your code is continuously authenticated and authorized. And also, when we are using such softwares, we make sure that it's we are using the same principles, like in terms of continuous authentication, validation, and then removal of implicit trust. So that's a very interesting intersection between zero trust and supply chains risk materialization using open source software.
Yeah, that's a very good point. Yeah, thanks for that.
Mhm.
I'm checking again. I don't see any other open questions, so I think that we'll go ahead and wrap this up. Again, this will be posted as soon as we finish processing the video, and of course, you can reach out to us at any time if you do have any follow-up questions. But thanks again for joining us and for viewing the webinar, and you'll hear from us soon. Thanks.